Hello guys, we are going to continue our discussion about triangles. Today we are going to discuss about isosceles triangle and equilateral triangle. But before that, let us discuss first the different classifications or kinds of triangle. There are actually two classifications of triangles according to the measure of the angles and according to the measure of the sides. Let us discuss first how to identify the different kinds of triangles according to the measure of the sides. There are actually three kinds of triangle according to the measure of the sides. We have acute triangle, obtuse, and the right triangle. Acute triangle is when you have a triangle whose angles are all less than 90 degrees. Okay, an obtuse triangle is when one of the angle in all those three angles is greater than 90 degree. So one of the angles should be greater than 90 degree. That is an obtuse triangle. A right triangle is when one of the angle is exactly 90 degree. That is a right triangle. Another classification of a triangle is according to the measure of the sides. Okay, we also have three kinds of triangles according to the measure of the sides. We have scalene. Scalene triangle is when all of the sides are different. The measure of all the sides are different. Isosceles triangle is when two sides of the triangles are the same, okay, or equal. We call it isosceles triangle. And the last one is an equilateral triangle. Equi, from the word equal, that means all sides are equal. Okay, so we are going to focus on these two kinds of triangle, an isosceles triangle and equilateral triangle, so that the topic or the discussion will be about these two kinds of triangle. Okay, let's start with an isosceles triangle. Okay, let us discuss the different properties of an isosceles triangle. The first property of an isosceles triangle is two sides are congruent. When you say congruent, that means they are equal or they have the same measure. So if a triangle is an isosceles triangle, they should have at least two sides congruent or equal. And what do we call those sides? We call them the legs. Okay, so based on this triangle, okay, based on the markings in this triangle, these two sides are congruent, therefore we call them the legs. Okay, so always remember the two equal sides are the legs. Okay, if you see those markings, therefore they are the legs. And what do we call the non-equal sides? Okay, the non-equal side is what you call the base. So leg, base. Okay, so the legs are equal, so therefore this is 7 units, therefore this is also 7 units. Okay, so the legs are always the same or equal. Alright, another property of an isosceles triangle is the base angles are congruent. Base angles are congruent or equal. Now, what do we mean by base angle? Where can we find the base angle? The base angles are the angles. We know that there are three angles. The base angles is formed by the leg and the base. So the base angle here will be this angle. Okay, leg, base angle. So we also have another leg here, so leg, base angle. So we have two base angles in an isosceles triangle. Okay, same with the leg. We have two legs, but we also have two base angles, and the base angles are congruent, so that means they have the same measure. So if this is 70 degree, therefore this is also 70 degree. Okay, base angles are always congruent. Okay, so to identify the base again, it is an angle formed by the leg and the base. Alright, so if the base are 70, 70, okay, what will be the measure of the third side? And this, third angle. The angle here, okay, so base, base, the third angle is what you call the vertex angle. This is the vertex angle. So that is the third angle in an isosceles triangle. And that is the non-equal angle in an isosceles triangle. Okay, so if the base are 70 degree, yeah, the base angles are 70 degree, so that will be, how do we find the measure of the vertex angle? Let's say the vertex angle here is x. Okay, so to find the measure of the vertex angle, we know that the sum of the three angles of any triangle is always equal to 180. So that will be 70 plus x is equal to 180, right? So this is 140 plus x is equal to 180. Subtract both sides by 140. So x is equal to 40. So therefore the vertex angle will be 40 degree. Okay, so I hope this is clear. Okay, so let's have here another triangle. So based on the markings, these are the legs. These are equal. So therefore these are the legs. Leg, leg. If AB and AC are the legs, therefore BC will be our base. Okay? Then let us identify the base angles. The base angle is an angle formed by the leg and the base. So therefore this will be a base angle and another base angle here. So angle B and angle C are the base angles. Okay, and they are equal. So if this is 10 units, this is also 10 units because the legs are always equal. If angle B measures, let's say this is 50 degree, therefore angle C is also 50 degree, right? So 50 and 50 because base angles are congruent. Now, how do we measure, or how do we get the measure of angle A? Again, the sum of the three angles in a triangle is always 180. So therefore angle A plus angle B plus angle C is equal to 180. We are looking for the measure of angle A. We know that angle B is 50 plus 50 is equal to 180. Angle A plus 100 is equal to 180. Subtract 100. Angle A is equal to 80 degree. So angle A is equal to 80 degree. Okay, let's have the next property. The altitude to the base is, when you say altitude, that is the height of the triangle. Okay, so when you draw an altitude from the vertex perpendicular to the base, this is the vertex and this is the base. If you form a segment perpendicular to the base, we call this an altitude. Okay, and based on the theorem, the angle, the base or the altitude to the base is what you call, is also an angle bisector. What do we mean by angle bisector? That is a segment that divides an angle into two equal measure. Remember, angle A here is 80 degree. This is 80 degree, right? Now, if this is an altitude, therefore it divides angle A into two equal measures. So therefore this is 40 and this is 40, right? Another property about isosceles triangle when it comes to its altitude is that the altitude to the base is perpendicular bisector to the base. When you say perpendicular bisector, the altitude is perpendicular to the base. Therefore, it forms a 90 degree angle. Okay. And bisect the base into two equal measures. So if this is point D, AD is an altitude, this is equal to this. So therefore, if the whole base measures 14 units, therefore this is 7 and this is 7. Okay, so that is how to, those are the properties of an isosceles triangle. Okay, let us have more example. Let us identify the legs, base angles, and the vertex angle of the following isosceles triangle. So let us have triangle HAP. Based on the markings, this HA is equal or congruent to PA, right? So therefore, HA and PA are the legs. So let us write here, the legs are HA and PA. Those are the legs. Now what is the base? The base will be HP. So leg, base. So HP. So if this is the leg and this is the base, this will be your base angle. So angle H and also angle P are the base angle. If angle H and angle P are already the base angle, therefore angle A will be your vertex angle. So angle A will be the vertex angle. Okay, let us complete the measures of the following parts. So if HA measures 6 cm, therefore PA is also 6 cm. If angle H is 80, which is the base angle, therefore angle P is also 80 degree. Now how do we get the measure of angle A? We know that the sum of these three angles is equal to 180, so that will be 80 plus angle A is equal to 180. This is 160 plus angle A is equal to 180. So angle A, when you subtract this to 160 both sides, therefore this is 20 degree. So angle A is 20 degree. Okay, let's have number 2. Okay, let us identify the legs, base angles, and the vertex angle. Okay, so based on the markings, AP is congruent to AG, therefore the legs are AB and AG. AB and AG are the legs, so leg, therefore this will be the base. So we can say that the base is not always at the bottom. You can rotate the figure. You can also flip the figure, so you can also have the base right here. So the base will be BG. Okay, so if this is the leg, this is the base, this will be your base angle. So angle B is the base angle. And another base angle is leg, base, this will be your base angle. So angle G is also a base angle. If angle B and angle G are also already the base angles, therefore angle A will be your vertex angle. Right? So we have the following. So base angle, vertex angle. Right. Now, if one of the leg measures 10 cm, AB is 10, therefore AG is also 10 cm. If the vertex angle is 80, how can we get the measure of each base angle? Okay, we know that the base angle are equal, right? So they have the same measure. So how do we get that? We can say that 80, let's say this is x and this is also x, because they're equal. So if this is x, this is also x. So x plus x is equal to 180, right? Subtract both sides by 80. So we have x plus x is 2x is equal to 100. Divide both sides by 2. So x is equal to 50. So this will be 50 degree, and this is also 50 degree. Or you can just simply say that since the sum of these three angles is 180, 180 minus 80 is 100, and then you divide 100 divide by 2 because they have the same measure, right? Okay. So 100 divide by 2, that is 50 degree, because they will share the same measure. Okay, next, okay, let's have this isosceles triangle. We have here triangle CAB is an isosceles triangle. Let us solve for x, y, and z. Okay, let's start by solving for x. If we want to solve for x, of course, we are going to use the expression with x variable. So we are going to use 3x minus 2 and x plus 38. And these are the measures of the base angles. So we know that the base angle in an isosceles triangle are congruent. So angle C is congruent to angle B because they are both base angles. The measure of angle C is 3x minus 2 is equal to angle B, which is x plus 38. Right? Now we are going to solve for x, so we want to combine all all terms or variables in one side of the equation, which is x. So I want to subtract both sides by x, so I can eliminate that on the right side. So that will be 3x minus x is 2x minus 2 is equal to 38. Now I'm isolating x, so I don't want minus 2 here, so I will add both sides by 2. So that will be 2x is equal to 40. Divide both sides by 2, because this is multiplication, the opposite is division, so x is equal to 20. Right? So the value of x is 20. Now to find the measure of the third side, of angle C, where did I get that third side? Okay, if x is 20, what is the measure of angle C? You just simply plug in the value of your x to the given expression. So 3x minus 2, if your x is equal to 20, so 3 times 20 minus 2, this is 60 minus 2 equals 58 degree. Right? Now, this should be also 58. So if that is x plus 38, if my x is 20, so 20 plus 38 is equal to 58. So they are equal to each other. Now let us solve for y. Solve for y, this is your y. Okay, so if angle C is 58 and angle y is also, angle B is also 58, therefore angle A, which is your y, will be the third side. So that will be 58 plus 58 plus y is equal to 180, because the measure of the three sides or the sum of the three sides is also always 180. So this will be 116 plus y equals 180. Subtract 116 both sides. Okay, so y is equal to 464. So this is equal to 64 degree. Alright, now let us now solve for C. How do we solve for Z? Z, here 2z and z plus 12, there are the legs, so we can say that 2z is equal to z plus 12. Subtract both sides by z. Z is equal to 12. Z is 12, so 12 plus 12 is equal to 24. So 2 times 12 is also 24. Okay, so they are equal. Okay, let's have Properties of equilateral triangle, that's very easy. When you say all sides are equal. So one property of an equilateral triangle is that all sides are the same or equal. So if this is this side, and these sides are all equal. So if this is 10, this is 10, and this is also 10, right? All angles are congruent. Since all sides are congruent, therefore all angles are congruent. If all angles are congruent, and we know that the sum of the three angles is 180, 180 divided by 3, we divide it by 3, so all angles are 60-degree angle. So all angles are congruent, and all angles measures 60-degree. Okay. The altitude, median, and angle bisectors and perpendicular bisectors are all the same and same lines. Okay, so if you have an altitude, that will also be an angle bisector, that will also be perpendicular bisector, and that will also be a median. Okay, let us solve for x, y, and z using this triangle, which is an equilateral triangle. Based on the markings, all sides are equal. Let us solve for the measure of all the variables. Let's start solving for x. Solve for x. Now, of course, if you want to solve for x, you are going to use the variable x here. If we know that the measure of all the sides in an equilateral triangle are always equal, so if this is 10, your x is also 10, right? X is also equal to 10, right? If this is 10, this is also 10. Now, how do we solve for y? Solve for y. How do we solve for y? If this is 10, this is 10, of course, y plus 3 is also equal to 10. So how do we solve for y? So y plus 3 is equal to 10. Subtract both sides by 3. Y is equal to 7. Right? So what can we add to 3 that will give us 10? Of course, that's 7. Now let us solve for z. Okay, so this is an angle. Okay, we said earlier that the measure of all the angles in equilateral triangles are all equal, and each angle measures 60 degrees. So this is 60, this is 60, and this is also equal to 60 degrees. So what equation can we use to solve for z? So the equation will be 3z is equal to 60 degrees, right? Because this is equal to 60. So divide both sides by 3. Z is equal to 20. So this is 20. So therefore, to check, 3z, 3 times 20 is equal to 60. Okay, so I hope this is a little bit long, but I hope you got the properties for these two kinds of triangle.